So slope was given by slope of any graph, whether it be position time graph, whether it be velocity time graph, any of the graph if it is there. So you can find out the slope given by the formula y2 minus y1 over x2 minus x1. So you will be from the graph you can take any 2 points. Suppose I have, let me draw a graph, a general graph I'm drawing. So here I have drawn a general graph. On this graph, we choose any 2 points. So the points before we call them as x1, y1. The points after we call them x2, y2. So here we get x1, y1. This is the coordinate of this point. And x2, y2 are the coordinates of the second point. So we can obtain here from the graph the slope of the graph. The slope can be represented as y2 minus y1 over x2 minus x1 for any position. For any of them, you can find out the slope of the graph. Right? Now, let us see, we had seen here that which all graphs are possible, which all graphs are not possible. Now, we'll be starting today with the velocity time graph. We will see what all are different velocity time graphs. So let's see there, velocity time graph. Let's see here. Velocity time graph. So let's take the, suppose we are plotting on the y-axis, we are plotting the displacement, and on the x-axis, we are plotting here we are plotting time. So this is our velocity, here you have time. So I'm plotting velocity versus time. Here I'm taking velocity in meter per second, and here I'm taking time in second. So let's take certain time intervals starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Similarly, let's take some velocity points here. So let's take, we have velocity as 2, 4, 6, 8, 10, 12, 14, 16, and 18. Now, in this velocity time graph, we can have again different shapes of the graph which are possible. So I can draw the some graph I can draw like this. Suppose I have a graph like this. So what can you say about this graph? What does this graph represent?
So the object is having a uniform velocity of 10 meters per second.
Okay, so object is having a uniform velocity. It is having a uniform velocity of 10 meter per second. Right? Now, if I have some graph like this, which is inclined, suppose I have a graph like this. So what can you say about this graph?
So the object is uniform accelerator.
Formally accelerate.
Yeah, here it shows that the object is accelerating and it has a uniform acceleration. So my graph,
uniformly accelerated, right?
yeah, it is accelerated motion. So here graph B, it shows accelerated motion. Here it shows accelerated motion and it shows that the object is accelerating. Okay, from this graph B, can you tell me the initial velocity of the object?
So the initial velocity was 2
Zero.
meters per second.
How much?
Is it
2
8?
meters per second.
See, at the beginning of the time, it has the velocity 2 meter per second. So initial velocity here for the graph B, I can write initial velocity U to be 2 meter per second. And what is the final velocity?
Or 8 meters per
8
second.
meter per second.
Okay, we can write here V equals to 8 meter per second. Can you find out the acceleration then? Okay, what is the
Yes,
time?
sir.
5
What is the
seconds.
time?
5 seconds, sir.
5 seconds. So can you tell the acceleration?
Sir, 1 meter per second. Oh, no, sorry.
So 0.12.
0.12.
12. Sorry, so 1.2, 1.2. 1.2 meter per second.
Yes, sir, 1.2.
Your acceleration would be 6 by 5. That is 1.25 meter per second, right?
Yes, sir.
So 1.2 only, 1.2 meter per second. Okay. So you got here acceleration from graph B. You got the acceleration for the graph A. For the graph A, it's moving with the uniform velocity. So I can say here acceleration will be 0. So to find out the acceleration, if I find out the slope of the graph, I can find out the slope of the graph, and the slope of the graph will give the acceleration. So slope is given by y2 minus y1 over x2 minus x1. So if I use this method, so I can take 2 points. Suppose I take this point as the final. Here I take the initial. So now if I use the coordinates, so this point has the coordinates 0, 2, and this point has the coordinates of 5, 0. So 5, 8. So I can find using this formula, if I get the acceleration, it will be the slope of this graph. Okay. If you have any non-linear graph, so that would represent a non-linear motion, that would represent changing velocity.
So
Got it?
what is non-linear graph?
Non-linear means if it is a curve, if it is any other line, so how you will observe this? So suppose you have this 12 and here the graph is something like this, or let's say it's like this. It's like this. So what does this represent? We observe that the graph is not a straight line.
Sir, it has non-uniform acceleration.
Yeah, it has a non-uniform acceleration. Now, one more very important point from this graph, area under the graph. So another very important question is asked from this, area under the velocity time graph. So here next we come. Okay, so all of you who are present in the class, welcome all of you. I want all of you to speak up during the classes. If you have any doubts, so do speak up. Even if you don't have doubts, so
Yes, sir.
answer. Okay, you should be either answering or you should be asking your doubts. Do not just sit like in front of your mobile or laptop and just watch. Okay, you are not a passive user. You have to be an active user. Okay? Just be active, ask your questions, clarify your doubts, and be smart. That is, when you have some work, suppose if you want to leave the class due to some urgent work, so do inform and leave. Without information, do not leave. Okay. So the next topic is area under the graph. Okay, so what is the area under the graph? The area under the graph or area under the velocity time graph, it represents area under the velocity time graph, it represents displacement. Area under the velocity time graph represents displacement. So let's say we have some graphs. So here I have taken a velocity time graph. Let's see. Again, the same graph I am taking, similar graph, similar to the previous one. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here you have 2, 4, 6, 8, 10, 12, 14, 18, 14, 16, 18, and 20. So area under the graph. Suppose I give you a graph something like this. Okay. I give you a graph like this. So can you find out the displacement here? Using the information given, can you find out the displacement?
Sir, I don't know.
Yes. What will be the displacement? Okay. How many of you can find out? Harshit, are you there?
Yeah, sir, is it 10 meter?
No, that's the velocity. Here I have taken, this is a velocity time graph.
That's 70 meter.
Okay, let's see. So this is our velocity which I have taken in meter per second. This is time. On the x-axis, I have plotted time in second. So what can you say about the displacement?
Sir, is it 0?
No. How can it be zero? The object is moving with a constant velocity. Okay, just do like this.
Sir, velocity into time is equals to displacement.
Yeah, velocity into time is equal to displacement. So it has a constant velocity of 10 meter per second and time is 7 seconds. So what will be the displacement?
70
70
meter.
meters.
Yeah, so displacement will be velocity multiplied time. That will be 70 meter per second, right? 70 meter. Now, if I tell you the other way, I tell you find the area under the graph. Can you find out the area under this graph?
Yes, sir.
So it represents a rectangle like this.
Sir,
Yes, it represents a rectangle. And can we
Oh,
find out the area of this rectangle?
yes, sir. It
Yeah,
will be
find out.
70 meters.
sir,
It
is it
will be,
140?
yeah,
Sir, it's some 70 meter square.
yeah. So area under the graph is numerically equal to displacement. It is numerically equal to displacement, not the units. Okay. You don't look for this, just multiply, you find out the area. So here length of this rectangle is 7 meter and breadth is 10. So multiply 10 by 7, that's 70 meter. Got it?
Yeah, sir.
Okay. Now see. Okay, let me take now a graph of some other
Sir,
shape.
isn't displacement V by T?
No, displacement is V multiply T. Velocity is V, velocity is S by T.
Okay.
Okay. Now let us have some graph of some other shape. Okay. So now I want to take graph of some other shape and try to find out the displacement. So suppose I have a graph like this. Okay. Now can you find out the displacement? Akshara? Akshara, Pranav. Pranav, are you there? I think, yeah, Pranav is good. Akshara, are you there? Can you unmute? If you can't unmute, so I just, okay. Yes.
Sir, we will
Okay.
be 35 meters.
Okay. What is the initial velocity here?
Sir, 4 meters per second.
4 meter. And what's the final velocity?
14 meters per second.
Okay. And what is the time?
We got
Sir,
displacement
7
98
seconds.
meter.
Yeah, the displacement. Or what do you get the displacement?
Sir, 98 meter.
28.
Okay. So now we find out the area under this graph. So the area under the graph would be, if I find out the area under the graph, so what shape do I find? Let me join this last side. So what shape do I have?
Sir, a
Quadrilateral.
quadrilateral.
A quadrilateral. And which type of quadrilateral is this?
Sir, so it's
Yes.
like a trapezium.
Yeah,
Trapezium.
it is a trapezium. And
Sir,
if do
it's
you
an
remember?
irregular trapezium.
Yeah, it's an irregular trapezium. And what is the formula to find the area of trapezium?
H into A plus B by 2.
Okay. Area of trapezium is sum of parallel sides. It's 1 by 2. Multiply the sum of parallel sides and multiply with height. It's 1 by 2 multiply sum of parallel sides multiply height. Got it? So you have 1 by 2 multiply with. Now, what are the parallel sides here? Let me mark them
4
O,
and
A,
14.
B, C. So what are the parallel sides here?
Sir, will you mark D also?
Yeah, this is O.
Sir, OC and AB.
Yeah, OC and AB are the parallel sides. And what is the length of OC?
4 meter.
4. Okay, OC is 4. And AB is
14
14.
meter.
14. So we have 4 plus 14. And what, Rohit, what is the
Height.
height?
The height.
Yeah, height of this
7.
trapezium.
7.
7. Okay, so height of this trapezium is 7. And if I find out this 1 by 2 multiply 18 multiply 7. So you get here, cancel this
63, sir.
9. 63
Meters per
meter,
second.
not meter per second. See, the
Sir,
area of the
63
trapezium is
meters
numerically
per
equal to
second.
displacement. So the displacement should be equal to 63 meter. Okay. Is there any way that we can verify this?
So we can use the second law of second equation of motion. We can
Okay.
find the acceleration and use the second equation.
Okay. So all of you try to use the second equation of motion. For the same question, where the information is given to you graphically, use the second equation of motion and find the displacement and verify that you are getting the same answer. So I'm writing here for your reference, I'm writing the formula as S equals ut plus 1 by 2 at squared. Okay, so you already know the initial velocity, you know the final velocity, you know you can find out the acceleration also. Okay, the slope of the graph will give you the acceleration. So use this method to find out the displacement.
Sir, yes, sir, we are getting 63 meters.
Are you getting 63 meter?
Yes, sir.
Okay, let everyone try it out. Let us try everyone. Rohit, are you getting?
I'm still solving.
Okay, Jitendra, Akshara, Sampath.
Sir, yes, sir. I got 63 meters.
Okay.
Yeah, sir, it's 63.
Okay. Okay, is there anyone who is not able to get it? Anyone who cannot find it out?
Sir, can you once explain with the second equation of motion? I'm not getting the right answer.
Okay. What is the value of acceleration that you are using?
Sir, actually, that's the thing I'm not getting. I'm not able to find the acceleration.
Okay, so acceleration will be given by either you use v minus u over t, or
Yes,
you use a y2 minus y1 over x2 minus x1.
yes, sir.
So you choose any 2 points. Like here we have the starting point. Here a y value is 4 and x value is 0.
There's a 4 minus 0.
No, it's not 4 minus 0.
Oh,
Okay, you take it like this. This is your final velocity, 14. So you have v equals to 14 and initial velocity u equals to 4.
there's a 14 minus 4 by 7.
Yeah, 14 minus 4 by 7.
Sir, which becomes 8.
So 14 minus 4 is 10. So
Yes, sir.
10 by
10 by
7.
7. 0.7.
Let it be 10 by 7 only.
Yes, sir.
Okay. Yeah, Akshara has verified. Anyone else? So you can simply, this graph is very important,
Yes,
that
sir.
in the velocity time graph, the slope of the graph will give you the displacement. Okay. So the slope of the graph will give you the acceleration.
Yes, sir. Sir, I got it. 1 second. Sir, I got 63. I verified it.
Okay. So how I think, okay, all those who have verified can raise their hands over here only. You can raise your hands so that I know how many of you have understood how to find out the displacement from a velocity time graph. Okay, Jitendra has done. Sampath, you haven't done. Okay, Akshara has done.
Yeah, done, sir.
Okay, Sampath, you didn't raise your hands through that one. Okay, so almost everyone has done. I think. Okay, I got everyone has done. Now let us. I give you another question. So from that question, I'll be giving from that graph. I'll be giving you certain questions. You just need to find out that. So here, okay. So this is a graph which I have provided you. Let's starting is O, A, B, and C. So these are the four portions of the graph. Here I have given you the time as 2, 4, 6, 8, 10, 12, and 14. Here I give you the velocity as 2, 4, 6, 8, 10, 12, 14. Okay. So my questions are, you have to find the acceleration during first 5 seconds. You have to find here acceleration during first 5 seconds, and during next 7 seconds, also acceleration during last 2 seconds. Then you have to find the displacement, and the displacement has to be found as total. You have to give the total displacement. Okay, so can you find out all these information? Jitendra, are you there? Jitendra, Sampath.
Yes, sir.
Yes, sir.
Okay, so try to solve out. You have to find the acceleration in all the three portions of the graph, and you have to find the displacement, complete displacement, the total displacement. Let me give you total displacement is to be found out.
Sir, can you once explain this concept as I was absent in the last physics class?
So it was the same thing which I explained just before.
Okay, sir.
Okay,
Still,
so
I'm
it is a
getting a bit
velocity. Yeah, it's a
confused.
velocity time graph. Just adding, I missed out. I'm adding here that it is a velocity time graph. Okay. The same thing we did in the previous class. The velocity is taken in meter per second.
Yes, sir.
Okay. So if you are not able to do, I will explain just, I'm waiting for 2 minutes. I will explain this. Okay. So how many of you can do this question?
Sir, I can do.
Okay. Okay, try out. And if you get your answers, do message in the chat. Okay, shall I explain this out? Okay, just see this first portion. So for the first, you have to find out the acceleration during first 5 seconds. So if I join the graph for the first 5 seconds, I obtain the graph OA. And for this graph OA, if I find out the slope of the graph, so the slope of the graph will give me the acceleration. Here I want to find out slope of OA or AO. So slope of the graph OA will be again equal to y2 minus y1 over x2 minus x1, or I can do final velocity minus initial velocity. So during the portion OA, is the final velocity here? Rohit, what is the final velocity during this portion of OA?
12.
From O to A,
4 to A. Okay.
so not 4 to O to A. The graph is from O to
4 to
A.
A.
So what is the final velocity?
Sir, final velocity will be 12, right?
Okay. So we can use directly the formula of acceleration as V minus U over T,
Yes, sir.
and the value of V is 12. So we get 12 minus initial velocity is
5, right, sir?
no,
No, 0, 0, 0.
0. So we have initial velocity as 0 and divided by time.
5.
So time is 5. So 12 minus 0 by
12 by
5.
5.
Yeah. Okay. So I have one answer here. Sampath has sent answer. Okay. So for this portion, we got acceleration as 12 by 5,
Yes,
which
sir.
is 2.4. Get 2.4 meter per second. Now for the next 7 seconds. If you
Sir,
observe
till
for the
12.
next, no, for the next 7 seconds, what is its velocity? What is the initial velocity for the next 7 seconds?
Sir, 0, right?
Initial velocity is 12. Final velocity is also 12.
Sir, so 0 by 5. No,
Yeah, it's
0
0
by
by 5, that's
12.
0. So here for the next 7 seconds, you get here acceleration as 0. Everyone is getting? Anyone who is not able to get?
Sir, it's during the last 2 seconds now, right?
Yeah, now you have to find the acceleration during the last 2 seconds. So find it out, everyone. I think Sampath has given the answer. All of you try to find out the answer.
Yes, sir.
Sir, is my answer correct, sir?
Okay, so for the last 2 seconds, okay, Harshit has also given the answer.
Sir, is my answer right?
Harshit, your first part is incorrect. For the first part, it's 2.4, not 2.8. Okay. And the remaining two are correct. Got it? Okay. So I hope keep trying, keep practicing. Today you will be getting one assignment completely. Try to do that with the help of the graph and everything is there. Okay. So bye all of you. See you again in next class.
So
Bye, sir.
Bye.